Atamate. So Atamate is a building control system which the objective is to reduce the energy use in buildings, to reduce the building management, reduce the maintenance while increasing the comfort for the occupants and the security. And we do that through automating all the building services.
So how, as an architect, how am I going to best make use of the system?
We think there's a lot of space for this type of technology is in reducing energy use in buildings, and particularly with new buildings. So if you were involved in new buildings, there's been a lot of work that's been gone into the fabric of the buildings and making them better insulated. There's not been as much thought that's gone into the building services of the new type of buildings we're going to get. And particularly because you've got to look at the different environments. And here in the UK, we're in a maritime environment, so we have much warmer winter temperatures than you would have in Central Europe or somewhere. So a lot of this type of technology has been coming out of Europe, coming out of Austria and Germany with things like the Passivhaus movement and such like, which has been a fantastic driver for change in the industry. But not necessarily those technologies should be applied directly to the UK.
Then there's also a wider need to make sure that we're connecting up to green sources of energy as well in terms of the wider grid, and that seems that you're able to make kind of quite an immediate change. And then there's also the obligation to making sure that that's really working in terms of connecting up to sources that are coming from solar from offshore. So there's that kind of wider story to it, to making it really green, depending on where the energy is coming from.
Absolutely. So, and I think we're going to see this with SAP10. So SAP10 changes the carbon factors, which is how the primary energy is produced, and we're expecting to see SAP10 come in to regulation later this year. And in fact, Mayor Khan in London has suggested that all London projects should be using SAP10 already. And so the SAP10 will encourage people to use electrical heating, essentially. Now, the issue is it's out of control bill. So typically electricity is going to cost 3 or 4 times as much as a gas bill, and therefore you don't want to have it running unnecessarily. So by linking it to the occupancy in the room, it's only going to be running when you need it, as opposed to running the whole time, and therefore it becomes significantly more efficient than the alternative solutions. And also, of course, we've got to go back to the reasons, is because the amount of energy you need to heat these modern buildings is so much lower, and responsiveness is what you want, and that's what electricity gives us.
Is actually quite different to a lot of the conversation that has been happening in the last few years, which has been pushing towards looking at communal heating systems. You're actually saying that this is a method of allowing to remove the plant room and units working each on their own to function as an individual setup. That seems exciting. So one of the points on that which seems quite exciting is the saving of space on plant rooms, which of course is something that on multi-resi, that's quite a lot of space to find. But then there's also this shift away from, potentially what you're suggesting is a shift away from the collective, the communal heating systems, to allow for each dwelling to be able to operate itself independently from others.
Absolutely. So each dwelling can become standalone. I mean, the advantage of control is it hugely simplifies and it gives alternate solutions to the building services. So by having this real detailed knowledge of when the building's in use and who's using the building, in essence, you can put in completely different mechanical systems.
I'm really interested in projects that are doing good in the broader sense, in a societal sense, in terms of sustainability. There was last year a fantastic project, the Goldsmith Street, that it won the Sterling Prize and has generated a lot of interest around Passivhaus. Now, I think it's incredibly exciting that what that has shown is that local authorities are starting to see that you can design beautifully, low energy, sustainable, and creating spaces that people are really, really enjoying. We need that. We need those examples within the industry. There's been a lot of focus on Passivhaus, and there's been discussion around that. What are your thoughts?
We're a massive fan of Passivhaus because we believe it's changed the industry, and so it's a great movement for change. But I think that maybe it lacks some flexibility on its approaches. And what we found in our own projects is that we can get similar energy levels. So we're getting energy levels of around 11 kilowatts per year per square meter on projects which are only built to Part L compliance, and so we're not having to build to the more prescriptive Passivhaus standards, and consequently we're using, U values are typically down about 0.15, and air tightness might be 3. On our projects we found that we can get down to 11 kilowatts per square meter per annum for heating on a Part L compliant building. So this is a building that's got U values of probably around 0.15 and an air tightness of 3. So significantly reduced carbon in its construction, and of course considerably reduced cost. So there needs to be some flexibility. Also on Passivhaus, they advocate that you must use MVHR type systems. Now, an MVHR system, essentially, as it extracts the waste air from the building, it puts it through a heat exchanger and it warms the incoming cold air from the outside, which is a very clever way of minimising the waste air. More and more of the evidence would suggest that this is really appropriate for very cold countries. So where you've got a big temperature difference between the inside and the outside temperature, so potentially in sort of Central Europe, and the outside temperature might be minus 10 degrees and the inside temperature is 20 degrees, it's definitely worth saving that energy. In the UK, particularly in the southern UK, we don't have such large temperature differences, and so you don't have a requirement. It's not so much energy to be saved, and certainly some of the works that Oxford Brookes has done and such like has shown that there's probably less value in retaining that air. When you include in the MVHR the necessity to put in large ducts around the building to minimise the amount of noise of the air moving through the building, and to make sure that you've got good separation between the inlet and the outlet air, it's quite a complicated and expensive process to put in. So alternative solutions should be investigated, and certainly looking at a demand control ventilation is significantly cheaper and easier to install and will give a similar result.
All right, so projects that you're using it on at the moment, where's it? What are the sort of examples where you're testing this?
I think one of the most interesting projects that we've had is that we've put it into 6 student flats, and we've been monitoring them quite closely and been working with Oxford Brookes University over a whole year. And in fact, we did it a couple of years ago. So we did it in a year when we had the beast from the east, and then we had a very hot summer, which was really interesting because we had much more extreme temperatures and how the building was designed to. And so what we did was that these were new build flats. So they're built to building regulation Part L compliant. But by putting in the control systems, what we found overall is that the best performing units, some of them were coming in at 70% below the SAP, where the SAP model suggested the amount of energy that would be required. And the overall energy was around 11 kilowatts per square metre, which is very favourable compared to sort of Passivhaus standard of 15 kilowatts per metre. But the key point is that we didn't have to build the fabric to the level that you'd normally get on a Passivhaus. So the air tightness of the building was not as good as a Passivhaus. I think it was around 3 on average, and the fabric installation, the U values on the walls and the roof and the floors were about 0.15, whereas again on a Passivhaus type build it'd be significantly higher. So in summary, we were getting the same results of the Passivhaus, but we were putting in a lower quality fabric, which is cheaper, has less carbon associated with that fabric, and obviously lower direct energy use as well.
And from an architectural point of view, where it seems really promising is that there is always, with M&E and architects, there's always a wrestling match for space, because we want maximum space, and of course all the ducting and the systems take up room, and that's always a bit of a tussle. So the potential from a design point of view is that it seems that what you're saying is there's more space to play with, because by having an automated system, it's really slimming down the spatial impact of the kit that you need.
Yeah, I mean, it's the control system itself doesn't require, space envelopes very, very small. But the advantage of a control system is that you can think innovatively about your mechanical systems, and consequently you can put in much more much smaller mechanical systems, which absolutely. And of course, the more you can shrink them, not only is that going to have cost implications, and it's not unusual for the projects we're involved in to find that on the M&E, on the mechanical plant side, you're saving a sort of 30% saving over traditional systems. But of course, there's a carbon implication on that as well, because they require energy to build and more materials and such like. So, we're very focused on trying to put in the smallest, the minimum systems you need to do the job.
Wet systems within a building. Now, I'm right now working on something where we're having to pin down the layouts quite early on to be able to then establish where all the radiators is going to go, and it would be fantastic if we can free up that space. Switching to an electrical based system seems to bring a lot of benefits for us as designers to be able to have greater flexibility.
Yeah, so wet systems have been historically used a lot because they're a way of moving around a lot of energy, and we've needed a lot of energy in our homes, to keep them warm. And it comes back to the same thing. If we're building a much better fabric, which we are, and we don't require the same amount of energy, so that gives us flexibility. So of course, by getting rid of the wet system, not only is there considerable capital savings up front, but there's also a reduction in maintenance ongoing, and there's a likelihood that you're going to reduce the problems with overheating.
So from a design point of view, one of the things that seems really exciting about shifting away from wet system to electrical based, one of the things is being able to alter layouts in a much more flexible way. Wet systems, we're very tied to how we can then arrange a room. So benefits of having an electrical system instead. What does the electrical system look like?
Well, electrical systems can come in a number of different forms. Increasingly, I think we're likely to see infrared heating. So infrared heating is really mimicking the sun, and the human's preferred way to receive energy is through infrared. So, and the advantage of infrared heating is it can be completely disguised. It could be plastered into the walls, it could be plastered into the ceiling. And so from an architectural point of view, you've total flexibility. And of course, our control system is based on a wireless system, so it's easy to retrofit.
You just mentioned wireless there. Can you expand a little bit on what you mean by that within the system?
Sure. So originally the system was a wired system, and that's how we designed it. And the first version was all wired. The problem with a wired system is that it's expensive to install, it's complicated to install, and it's not retrofittable. And in 2017, the Bluetooth Foundation brought out the Bluetooth mesh technology, and so we've now migrated our technology onto this Bluetooth system. And the advantage is that you have a very robust signals going around the building, so it's a very robust way to communicate. It's a high level of security, it's bank grade security, and obviously people are very familiar with Bluetooth because it's already in many devices. So this means now that essentially we just need a power supply to connect to different devices. So it might be the sensor unit, or it might be you want a door release to control access to a room, or it might be that it's a light or a heating fitting. And on top of this, what's really exciting in the Bluetooth world is there's more and more of these devices which are called energy harvesting devices. An energy harvesting device is a device which takes the energy, maybe it's a sensor, and it takes the energy from maybe a little solar panel. So think of a solar panel like your calculator, the solar panel on your calculator, and it takes that energy and it will store it. And then when something happens, maybe a window gets opened or something, it can then transmit a signal, and that could just be done locally, but it will be picked up by our permanently powered sensors and then communicated across. And we're seeing more and more of these type of devices coming onto the market. So all sorts of things, from light switches to window sensors to occupancy sensors through to actuators, which are TRVs. So the thermostatic radiator valve, you can replace that now with a Bluetooth one. So it makes, again, a lot of this might be retrofittable, but it makes it much, much easier to install this type of control into existing buildings.
You just mentioned energy harvesting, which what I'm quite interested to hear about is thinking about data harvesting. So at the moment thinking around future cities, and there's a lot of discussion at the moment around so much more tech within cities, smart cities. Data and security, what's your take on that?
Well, absolutely, and I think generally in society there's got to be a compromise. Most of the information we're collecting is relating to the building. Of course, some of that is related to occupancy. So if you walk into the room, then we know that someone's walked into the room. We don't actually know it's you who's walked into the room. It could be me in the room. It could be the dog that's walked into the room. So it's not very personalised. The only time that our data becomes very personalised is if we're using like security systems and such like. And so clearly, if you're doing a PIN entry, maybe you're swiping your phone to gain access to a room or an apartment, for instance, then of course at that point in time we know that it is you individually who've entered that building. Of course, if you and your friend go in and one goes left and one goes right when you enter the room, we don't know that you've gone to the kitchen and your friend's gone into the living room. So actually the level of personal information we collect about people is significantly less than they'd be using on their mobile phone, for instance. So we don't believe that it's very intrusive, the information we're collecting, and it's fully GDPR compliant.
Well, what's the genesis of the company? Why did you set this up in the first place?
So my background is environmental engineering, so I've always had an interest in reducing the impact on the environment. I've spent many years running property development and building companies and building low energy buildings. And generally I realised that we were getting better at building fabrics, but we didn't see that. I didn't see that same level of development in the building services. Other things we commonly use in society, like our mobile phone and our cars, we see a huge improvement on usability and intuitiveness and efficiencies and all that. And we weren't seeing that kind of growth in buildings, and I knew it could be done better. And the advantage of putting in the control system in the building is that not only can you reduce the environmental impact, which is directly related to the building's heating, but there's also a considerable environmental impact on the building in terms of ongoing maintenance. And so the advantage of putting in an Atamate type system is that you can reduce the maintenance in the building, you can reduce the management in the building. And of course, management, if you can get rid of all your bunches of keys, if you're letting agents and such like, it means that you're going to be reducing the amount of carbon miles you've got for contractors driving back and forth to the office to go and pick up keys and return them and such like. So it's not as simple as just the efficiency in the building. It's the whole energy piece around the use of that building, which is, I think, that people really need to focus on. And that's where we believe in Atamate that we can make a real difference.